So this is how you can automate using Terraform and CI/CD.
In this DevOps project, you will learn how to automatically set up infrastructure on AWS using Terraform and GitLab CICD. Throughout the project, we will be using industry best practices like using modules, S3 backend, and lot more to set up a CI/CD pipeline. So if you're interested to learn how you can automate all this, make sure you like this video and subscribe to the channel. Let's start.
Alright, so I'm here on my computer screen and let's start with our Terraform pipeline project. But before we do that, let me just tell you, this is a bit advanced project that will require you to have knowledge on Terraform, GitLab, and also CI/CD. To help you with that, I do have videos already created. So make sure you go through this particular video to understand what is Terraform, how it works. Also some advanced concepts like meta arguments, modules are explained in this video. And I highly recommend you going through this video if you are very new to Terraform, just to make sure that you understand the concepts described in this particular project. Along with this, also check out this particular video which explains how CI/CD works, what is CI/CD, why we use it, just to understand the concept. And the next video that I need you to check is the GitLab CICD video, which is a 1 hour tutorial explaining jobs, stages, everything that we are going to be using in this particular project. So make sure you go through these 3 videos before you start doing this project. As I told you, it's a bit advanced and you will not be able to understand completely if you don't have prior knowledge to Terraform, GitLab or CI/CD. Now moving forward, this project is going to be divided into 2 parts. The first part is where we write the Terraform code, run the commands manually and see if everything is working fine. If everything works fine, we go to the second part of the video or the project, which is to automate all of these using CI/CD pipeline. So we will create a CI/CD pipeline configuration on GitLab and we will automate all of these processes using a pipeline script. So this is the second part of the video. First part, we write the code, run the commands and do everything manually to make sure our infrastructure is created on AWS, and then we automate it in the second part using CI/CD pipeline script. So this is the overall agenda of the project, just to give you an idea. Now before you get started with this project, there are a few things you need to have. The first is an AWS account. If you don't have an account, you will not be able to create any resources. So make sure you have an AWS account. Second is to have Terraform installed. I already have it. So if I show you by running Terraform -- version command, you can see Terraform is installed. You can simply install it by searching Terraform install Windows, Mac or whatever operating system you are on. Next, you also need to have GitLab account. We are going to create repositories and pipeline on GitLab. So you will need to have GitLab account created as well. I already have it. You can go ahead and create it and also verify it using your credit card, or else you will not be able to run pipeline. There's no charge for you to do it. Just for verification you will require a card. I've explained all this more properly in the video that I've told you here, so make sure you go through it. Along with this, you also need AWS CLI installed. We are going to connect our AWS with Terraform by running AWS configure command. So you will need to have AWS CLI installed. I already have it installed and you can check the version is 2.15. For you to install it, just simply search for AWS CLI download and you will go to the AWS documentation that can help you install AWS CLI. Very easy. Next, you also need a code editor. We are going to write Terraform code in a code editor. Most likely it's going to be VS Code. I use VS Code, so you will also require to have VS Code installed if it's not there for you. So these are few things to keep in mind before we get started with the project. So now we are all set and ready to get started with our project. For this particular project, I am going to create a folder inside my projects directory. So let's create a folder named as CICD TF. You can name it anything you want. This is just creating a new folder. If you are new to Linux, you might think what is this command, but it's just a mkdir command which creates a directory or a folder named as CICD TF. I'm going to open this up in my VS Code to start writing Terraform code. So now this is opened up in my VS Code. Let me pull it up here. This is how it should be. Inside this, I'm going to start writing my Terraform code. Now, if you're new to Terraform, you will have to go through the video that I told you. But whenever we start writing code in Terraform to create infrastructure on AWS, Azure, anywhere, we start with defining a provider. A provider, if you don't know what it is, you can just search for Terraform providers and you will see the list of things or list of cloud providers that Terraform supports. We are going to create infrastructure on AWS, so we need to define AWS as a provider. Terraform supports all these different providers. For this project, we are deploying stuff on AWS, so I will start with defining AWS as a provider inside a file named as provider.tf. So in this, I'm going to define a provider, which is going to be AWS. And inside this, I'm going to define some configuration settings like region. So I want to use a region which is going to be US-East-1, which is the North Virginia region. So for now, I'm going to put the values, but later on, to make sure I follow all best practices and do the things as we do in production, I'm going to variabilize and also use modules. So beforehand, I'm going to just create a variables.tf here and a main.tf file for now. Okay, so I've defined my AWS as a provider. I have my main.tf, I have variables.tf. As I told you in the start of the project, we are going to use best practices and follow the same things as we do in production. So we are going to deploy a VPC, security group, EC2 instance, and later on when we have a CICD setup, we might create more objects as well. For now, as we are creating VPC and EC2 instance, we are going to create two different modules. If you don't know what module is, again go through the video to understand what is a module. Modules in Terraform is a container for multiple resources that are used together. So we are going to use module to create everything about VPC in one module, everything about EC2 instance in another module. So let's do that by creating a folder. So I'm creating a folder named as VPC, which will have everything about VPC in here. So VPC, subnets, security groups, everything. Inside this folder, I'm going to create three different files. First is going to be main.tf. The second is going to be variables.tf. And the third file is going to be outputs.tf. You're very soon going to understand why we are having all these files and how we will use them. Along with this, I'm also going to create another module for EC2 stuff. So I'll create another folder and name this as web. Module name can be anything. It does not have to be the name of the service. I'm going to say web. Inside this, I'm going to create three files again, main.tf, variables.tf, and outputs.tf. Okay. All right. So we are now ready to get started with writing the code. Inside this files, I'm going to start writing the code for a VPC, a subnet, and a security group. So we will start. So we will create one VPC, one subnet, and one security group. This is not a project where we set up infrastructure for a complete application. This is just a project to explain you how you can use Terraform with CICD to automate your infrastructure provisioning. This is why we are just creating VPC, subnet, and security group. If you want to see other projects, check out the channel. I've created many projects using Terraform, Kubernetes, and everything else. So for this, let's start with defining a VPC. So I'm going to create a resource and it's going to be AWS_VPC. The name of the VPC I'm going to give is going to be my VPC. Inside this, we are going to add some configurations. First is the CIDR block. This VPC is going to have a CIDR block of 10.0.0/16. For now, as I said, I'm going to put the values directly, but later on variabilize it to follow best practice. Along with this, I'm going to say enable DNS hostname is going to be true and enable DNS support is also going to be true. Now, if you're not sure what is this DNS hostname, what is this DNS support, you can always use the official documentation. So if you just search for AWS VPC Terraform, you will go to the official documentation for this particular resource, and below you can find argument reference on what is CIDR block and also enable host name. You can see DNS host name support is also present. So every time you're confused about anything, feel free to use documentation. Terraform has one of the best documentation in the DevOps tools. So now along with this, I also need to add the name of my VPC. So I'm going to say tags, and the tag is going to be name equals to my VPC. Okay, this is the code for our VPC. Along with this, I'm also going to create a subnet and a security group as we have discussed here. So I'm going to say resource is going to be AWS_subnet, and this is going to be public subnet. So let's say pb_sn, and inside this, I'm going to pass in some configuration again. This subnet belongs to this particular VPC. So I'll say VPC ID equals to AWS_VPC.myVPC.id. So AWS_VPC.myVPC.id. Next, I'm going to add CIDR block. The CIDR block is going to be 10.0.1.0/24. This is the CIDR block I want to keep for my subnet. Again, I also have a separate video explaining how to create VPC, subnet, in internet gateway, route table, everything. So make sure you check that out if you want to learn more about how to create VPCs and subnets in Terraform. Now after the CIDR block, I also need to map public IP on launch. So I'll say map public IP on launch equals to true, and this should be in US East 1A subnet. So I'll say availability zone is going to be US-East-1A. Okay, along with this I also need to add the name for this. So I'm going to say tags is going to be name equals to pb underscore sn1, public subnet 1. Now this is the code for creating AWS subnet. Next we are going to create resource security group that is going to be attached to our EC2 instance in this web module. So I will say resource is going to be AWS underscore security group. So security group is here, and the name of the security group I want to say is going to be SG. Inside this I'm going to first define where is this security group going to be created. So it will be created in this VPC, which is aws vpc.myvpc.id. So the VPC ID is aws vpc.myvpc.id here. Next, the name of this is going to be mysg. So I'll say name is going to be my underscore sg. Description, if you want you can add it, if it is optional. So I'll say public security group here. So public security, and then I'm going to define inbound rules and outbound rules. So inbound rules are defined using ingress and outbound rules are defined using egress. So for ingress I'm allowing port 22, which is the SSH port, and for egress I'm allowing everything. So I'm going to say ingress is going to be from port 22 to port 22. Protocol is going to be TCP. So protocol is TCP, and CIDR block which is going to be allowed is going to be 0.0.0, which means everyone who has the keys can access my AWS EC2 instance if this security group is allowed. So I'll say 0.0.0/0. Okay. Now this is CIDR blocks. So we will have to put this in square brackets because you can have more than one CIDR blocks in a security group. So I'm going to put this in square, or else we will get an error. Okay. Now this is done for ingress. Let's do the same for egress. So I'll say egress is the outbound traffic, and I'm going to say from port 0, because I'm allowing everything from port 0 to port 0. Protocol is going to be -1, and then I'm going to say CIDR block is going to be the same value, which is 0.0.0.0/0. Okay, so this is our security group, which is now ready. Let's quickly also create an EC2 instance in our web module here. So in this I'm going to create an EC2 instance which will have security group that is created here in the main.tf, and I'm going to show you how you can use a value from one module to another, which is a bit complex to many DevOps engineers. So let's start with creating a resource. I'm going to say resource is going to be AWS underscore instance. So AWS underscore instance, and the name of the instance I'm going to say is our server. Okay, inside this we need to pass in some values like AMI, instance type, security group, subnet, and so on. So I'll put the AMI. I want to use Amazon Linux, so I'm going to get the AMI for Amazon Linux, which is here. So you can simply just get it from your account, or else it will not work. It's account and region based. So I'm going to get from my account in North Virginia because I'm using US East 1. Now next thing I want to put is going to be instance type. So instance type is going to be T2 micro. We want to stay in free tier limits. So I'll say T2 micro here, and I also want to use subnet. So I'll say subnet ID is going to be the one that we want from here. So this subnet, this is where I want to launch my EC2 instance, but this is in different module. So how can you get one thing from one module to another module, which I will show very soon. So we will keep this blank as of now. Similarly, I also want to have security group. So I'll say security groups, and this is also something that we will get from this particular module. We want to use this security group for our instance. So I will very soon show you how you can use it from one module to another. For now, let's get everything else done. Along with this, I also want to have tags. So I'll say tags is going to be name. Okay, tags equal to name equals to my server. Okay, now let's get the values of subnet ID and security groups. Before I show you how to use values from one module to another, let's understand the concept of modules. You can also learn it from the official documentation here, which explains very properly about modules, what is root module, what is child module, how can you use stuff, and how to create a module. So the concept is this main.tf is the root module or parent module where you will be calling all these child modules. This VPC and web is the child module. And if you want to pass some values from one child module to another child module, you need to first specify the value as an output in the module that you want to transfer it from, and then call it as a variable in the module wherever you want to use it. If this is not making sense, let me show you. In this module, we want to use subnet ID and security group from the VPC module here. So let's get this security group and subnet as an output so that web module can use it. So I'm going to create an output here by saying output is going to be pb_sn, which is the security group, and the value of this is going to be AWS_subnet pbsn.id, because this is what I want to use here in my main.tf. Now along with this, I also want to have security group ID here, so I'll also get that. So I'll say output sg, and then I'm going to hold the value which is going to be AWS_security group.sg.id. Okay, now we have created outputs for the things we want to use in this module. Let's use this by creating as a variable. So I'm going to say get the variable. So I'm going to say create a variable with the name sg. The name could be anything, and I'm going to keep this blank for now. Let me show you how we can reference the value. I'm going to create a variable for subnet, so I'll say sn, and I'm going to keep this value blank as well. Let's use this in here. So the variable for subnet is variable.sn, so var.sn, and the variable for security group is sg, so var.sg. Okay, so now we have defined the values in output here, and we have defined the values here in variable. To start using it, we first need to call the module in the root module. So I'll say module block. The name of the module block is going to be VPC, and we need to fill in some details. The first is source. Where is this module located? So this module is located inside this particular directory in a folder named as VPC. So I'll say ./VPC. And then similarly, I'm also going to do the same for my second module. So I'll say module EC2, and the source is ./web. Okay, so we have called it. Now you see a red error here which says there are a few things that I need to add. The first is the SN and the SG here. So what is the SN and what is SN and NG that you have described here in the variable? So I'm going to put that now. SN is the value that is stored in the main.tf, which is a subnet ID, and I've defined output here. So to call something or to get a value from one module to another, you need to define it by saying module name, output name. And you can also check it here, accessing child module outputs. So you will have to use it somewhere like this, module.module name.output name. For example, you can go ahead and read it if you want to. So it's going to be module.module name is VPC, and the output name for SN is pb_sn. So the value should be from here, pb_sn. Similarly, I'll also do the same for SG. So it's going to be module.vpc.output name. The output name for security group is just SG. So I will also do the same here. So pb_sg. Okay. This is how you use modules, and this is the way we create infrastructure in Terraform. We don't just do it in a single file. We categorize it using modules, as I have done it here. When you have a huge infrastructure, you will have more modules for databases, for networks, for VPC, and a lot more. It depends on how you categorize your application, but this is how we do it in our production environments. So our code is almost ready. Let's try to see if it actually works or not. And to do that, I'm going to run the Terraform commands. Before I actually run the Terraform commands, you need to connect your AWS with Terraform if you haven't done it already. And you can do that by running AWS configure command. I also have a video showing how you can connect AWS with Terraform. You can check it out here, but it's just adding your keys after running AWS configure. So I already have my keys added, and I'm also going to show you how you create these keys in the second part of the video, because we will require this when we set up our CICD pipeline. So if you have done this already, it's good. If not, just go through the video or wait for me to show you how to create keys so you can put it here. So I am already connected to my Terraform with AWS. I'll say Terraform init command. This is the first command we need to run to initialize our Terraform, to install everything to work with AWS provider here. So I'll say Terraform init. Also make sure you are saving all the files. or else you will get an error. So I'm going to just save all the files that I created till now, and once I save it, I'm going to then run Terraform init command. This is going to initialize the backend, initialize modules. We have a folder created which is having modules, and we'll also have provider folder very soon here. So this is how Terraform works. We first init it, then we are going to run the next command, which is validate, plan, apply, and then if you want to destroy it, we are going to destroy it. So let's wait for this to be initialized. Okay, so Terraform has given us output saying Terraform has been successfully initialized. Let's check if our code is proper or not, and we can do that by running Terraform validate command. So I'm going to say, let me just Terraform validate. It says the configuration is valid, which means our code is perfect. Now I'm going to run Terraform plan command to see what is going to be created. According to the code, a VPC, subnet, security group, and EC2 instance should be created. So 4 things should be created. When I run Terraform plan, it gives me an error saying string is required. Okay, we have got an error somewhere here. So it says security groups var.sg is a string. Set of strings is required, which is true. So I'm going to go to my main.tf. In this, it is asking us to put set of strings rather than just strings. So all I need to do is to put this in my square brackets because it's asking for set of strings. So let's put that here, save it, and try Terraform plan again. These are some of the troubleshooting skills that you need to know as a DevOps engineer so you can work things around. You can see the error is now gone, and we have 4 things that is going to be created, which are VPC, subnet, security group, and EC2 instance. So which means our code is now running properly. I can also run Terraform apply to actually have this in my infrastructure. Let's try running it to see if it is going to create it or not. So I'll say Terraform apply -auto -approve. Okay. When I run this, you can see a terraform.tf state file is also present here. This is not a good practice to have your Terraform's TF state in local machine. So we are going to very soon set up a backend so that this state file is going to be stored on S3 using DynamoDB as well. So this is how we do it in production. We never store it in local machine. I will also show you how to do it. In fact, I already created a video to show you how to set up remote backend on S3 and DynamoDB. So you can check it out here. Now this is creating, it has created VPC, subnet, security group is also created, and now it is creating an instance. To show you, let's go to the dashboard, and you will very soon see an instance in pending state. So let me show you that. I'm in North Virginia region, and let's remove this tag. You will see a server is now in pending state, which is my server as we have defined in here, my server. So this means our code is running properly and everything is working fine. So we are now ready to set up backend on S3. Once we do that, we are going to push the code on GitLab and start with the second part of the project, which is to create CICD pipeline to automate all of this. So it's working fine. Let's go ahead and delete everything. So I'm going to go ahead and delete this by running Terraform destroy -auto -approve, and this will start deleting everything that we have created. Okay. Now I have my code variabilized and it's following all best practices. Let's go ahead and set up backend using S3 and DynamoDB. I've already created my S3 bucket and also a DynamoDB table. Let me show you. So this is S3 bucket that I'm going to use along with a DynamoDB, which is used for state locking. I have explained how to do this very properly in a video, so make sure you check that out, or else you can simply just search for S3 state backend and you will come across Terraform documentation which explains how you can use S3 and DynamoDB along with this configuration to store your state on S3 rather than storing it locally. So we need to create a backend something like this. So I'm going to just copy this. I can also optionally type it if you want to, but to save time I'm going to copy and say backend.tf. Inside this I'm going to put the code and fill in my details, which is going to be the bucket name that I have. The bucket that I'm using is going to be the keys. Where do you want to store inside where do you want to store inside the S3 bucket? So I want to store inside a folder named as state. So I'll put state here. And the name of the bucket is my state Terraform 23 something. So I'm going to put this here. Region is US East 1. Along with this, I also want to have DynamoDB table for state locking. State locking means whenever many people are changing something that can affect the state, DynamoDB will lock it for one person at a time to avoid corruption of state file. This is state locking. So I'm going to put the name of the DynamoDB table that I created, which is here. So I'm going to tables. The name of the table is backend. So I'm going to use that here. Okay. Now we have backend configured. To start using it, I will have to run Terraform init command again, and it should tell me that the backend has configured as S3. So let's see if it does that or not. I'm going to save this first and run Terraform init. You can see initializing the backend. And it says successfully configured backend S3. Terraform will automatically use this backend unless the backend configuration changes. This means we have also followed the best practice to store our state file on S3. This has brought us to the end of the part 1 of the project, where we are doing things manually. We have created all this code and also ran Terraform commands manually to create all this infrastructure. To automate this, let's move to the part 2, where we are going to create GitLab repository, push this code on that repository, set up a CI/CD pipeline, and automate all this process. So to push this code, I'm going to first go to GitLab and create a repository. So I'm here in my GitLab dashboard, and you can see some repositories already created. These are the repositories that I used to teach you GitLab CICD in the video that I've mentioned here. So make sure you check it out if you want to know more about GitLab CICD, because we are going to create a CICD configuration file in this part of the video. Before we do that, let's go ahead and create a repository. I'm going to click on new project option here, create a blank project. Let's name this as CICD TF if the name is available. I'm going to make this public and initialize with a readme and click on create project option here. Now once it is created, I can run this commands here to start pushing my code from my local machine to this GitLab account. Before I do that, I first need to initialize my Git repository here. So I'm going to say git init. This initializes the repository, and now you can run the commands present here to push the code. Now before we push the code, there's also one more thing we need to add, which is the git ignore file. So if I search for git ignore Terraform, you will get a file that you need to use so that you push only necessary things, avoiding anything that you don't want to push, which is this thing. So I'm going to simply copy this and create a new file here with the name .git ignore, and I'm going to paste all this here. Okay, now we are going to push this by running the commands. Before I run the command, let me connect with my GitLab repository here by running the command git remote add origin test. So I'm going to run this command, and now if I show you, git remote -v command gives an output saying this is the repository that you're connected to, so you can fetch and push things here. So usually right now we are on the main branch. In GitLab, the main branch is always protected, and that should be the case because we don't push directly on the main branch in production. We rather create a separate branch, and then if everything is okay, we merge it to the main branch. So I'm going to do the same. I'm going to first create a branch. So I'll say git checkout -b, and let's create a branch named as dev. So it says switch to branch dev. Now in this branch, I'm going to say git add dot git commit -m initial commit, and then I'm going to say git push -u origin dev. So I want to push the code from my local machine to dev branch in my GitLab. Once I do that, it's going to ask me for my username and my password, and after I enter that, you can see it started pushing. Very soon, if I refresh the page, we will see a dev branch has been created, and there's an option to create merge request. So this is how we push the code. We push the code in the dev branch or any other branch apart from main branch. If everything is okay, we create a merge request. The senior DevOps engineer or anyone is going to merge it so that the code can be seen in the main branch here. So I'm going to create a merge request myself, and you can describe it if you want to. For now, I'm not going to give any information. I want the branch to be deleted after it is merged. So let's say create merge request. I am going to review this merge request. If it was someone else, let's say a senior DevOps engineer, they would review the merge request, see what changes have been done and everything else. If everything is okay, they will just go ahead and click on merge, and the branch will be merged, every code in the dev. So initial commit dev into main. Now it is merged, you can see here as well. Let's check that in our repository. So all the code is now present in the main folder, main branch here. So this is the code which is ready. Now we are ready to start creating our CI/CD configuration script. So to do that, I'm going to click on this plus symbol here and click on new file. To create a CI/CD pipeline in GitLab, you need to follow a naming format which is .gitlab-ci.yaml file. This file helps GitLab understand that the configuration inside this is CI/CD configuration. I'm again reminding you, if you're new to GitLab CI, please check out the previous video. It will explain you what a stage is, what are jobs, what are images, and also other things that can help you write and understand the CI/CD pipeline we will be doing very properly. Okay, so what is the use case of this? Why are we creating a CI/CD pipeline? We are creating a CI/CD pipeline to automate Terraform commands so that whenever a person makes a change in the infrastructure, which can be anything, let's say rather than having one EC2 instance, they make it two EC2 instance, or they added a new security group, or they added a new subnet. The DevOps engineer don't have to manually run the commands. It will be done through CI/CD. CI/CD will check it, plan it, apply it, destroy it automatically whenever a pipeline is triggered. So this is what we want to be done using this script. So the first thing we are going to do is use an image that will let us run Terraform commands. So we need to use an image that has Terraform capabilities. So I'm going to say image, and the image that I want to use is going to be the Terraform image, which is present on the GitLab registry. So this is the Terraform image that I want to use, which will let us run Terraform commands. Along with this, I'm also going to set the entry point. So this is the entry point and also the path where all my binaries and dependencies are stored. So this will let us run Terraform commands, and it's very important. I've explained image much detail in the GitLab video, so make sure you check it out. Now, in this pipeline, there are going to be 4 different stages. Validate, which is going to check the code. Plan, which is going to check what is going to be created or deleted according to the code. If everything is okay, run the Terraform apply command, and then lastly destroy. So we are going to have 4 different stages. So I'll say validate, plan, apply, and destroy. Okay. Inside each stage, I want to run particular commands. So here I will run the Terraform validate command, here I will run plan command, here I will run apply command, and destroy command, so on. Now let's define jobs. So jobs, I'm going to use the same name for the jobs as well. So I'll say validate. This job belongs to a stage which is validate stage. So I'll say validate here. Inside this job, I want to run a command which will be done using a script parameter here. So I'll say script and run the command which is going to be Terraform validate. Okay. Next, I'm going to go to the next stage, which is the plan stage here. So I'll say inside the plan, this belongs to the stage which is plan. In this, I'm going to say script and run the command Terraform plan, but also output it in a file named as plan file. So if you don't know what that command is, let's go back to our VS Code here. And if you have run Terraform plan before, you might know when you can also use -out parameter to save your plan into a file, and we will do that here. So let me show you. This is the -out equals to path. Write a plan to a given path. This can be used as an input to the apply command. This is what we are going to do in our CI/CD configuration here. So I'll say Terraform plan -out equals to plan file. If I want to make sure that the plan that is created here is saved in a file and can be used by another stage, which is apply stage here, I need to define this as an artifact. So in GitLab, whenever you want 2 stages to use something, you need to define it as an artifact, which is explained again in this particular video. So I'm going to define an artifact saying save the file, and so that it can be used in the next stage. So I'll say artifacts is going to be path, and I want to save this particular plan file. This is our plan stage, and we want the plan to be running only when the code is correct, only when the validate stage is passed. So this has a dependency saying that plan should run only when the validate is completed. So we will add a new parameter saying dependencies, and we are having dependency with the validate stage here, which means if validate passes, only then the plan should pass. Okay, now this is our second stage. Let's go to third stage and create a job for it. So I'm going to say apply job, apply, and the stage it belongs to is apply again. Apply should also run after the plan is completed, so I will say dependencies, and it has a dependency with the plan job here. Okay, now inside this I want to run a command which is going to be terraform apply, and then use this plan file to apply it. So I'll say terraform apply. Along with this, there are also no variables or inputs that you need to add as a user. So I'm going to say input equals to false, or else sometimes you will see that your Terraform, or else sometimes you will see that your CI/CD pipeline is stuck because it is asking for some input from the user. This is not the case for us. So I'm saying Terraform apply hyphen input equals to false, and then apply whatever is defined in this plan file. This will only be possible when we have artifacts, because only then we can pass things in different stages. This input only has one dash here. Lastly, we have destroy job. So this job belongs to the stage which is destroy, and it also it runs a command which is going to be terraform destroy hyphen auto hyphen approve. So I'll say terraform destroy hyphen auto hyphen approve. So approve. So these are 4 stages that we want to be automated using CI/CD, but there's still a problem with this file here. Before we actually run this commands, we need to make sure that Terraform is installed and it is also initialized so that we can use with AWS or any provider that we have defined. So what we need to do is add another set of code here which should be running before the stages are running. So we are going to say before underscore script. This means run this particular commands before you actually run the pipeline. So in this I'm going to run 2 commands. The first is terraform -- version command. This will help us know that this particular image has Terraform installed in it, and we also can see the version in the logs. Next is terraform init command to initialize our provider backend so that it works properly. So these are the 2 commands we need to run before the script is running. Now in our local machine, I have AWS configured properly with my keys and secret access keys, but how will GitLab know which account do I want to create infrastructure to? So we need to also use our access keys and secret access keys here in this GitLab CICD. So how can we do that? We can do that by defining the values directly in the code, which is not the best practice. So we would rather create a variable. We will create 2 variables actually, one for access key and one for secret access key. Before we do that, let's go and get the access keys from IAM here. So if you don't know how to do it, let me show you that very quick. I am right now logged in into a user, logged in with the user named as Nasi, which is an IAM user. So I'm going to use the keys for the same. If you don't have an IAM user, you can simply create it from here. After you create it, just go to whatever user you want. I'm going to go to this user and select security credentials option here. In this, if I scroll down, I have access keys. At times you can have 2 access keys, so I have 2 already. I'm going to delete one of them. So I'm going to deactivate first, then copy this and paste it here, delete it. Now it is deleted. I'm going to create another set of keys. You can use any option here, CLI, I understand, next, no need for description, next, and now I have the keys. So I'm going to use these keys to make sure that the GitLab will authenticate and also connect to my AWS, so that every time the CI/CD is running, it applies on this particular account. So I can optionally go ahead and put it directly in the code, which is not the good practice, and maybe your account might be banned because GitHub bans your account if it finds access keys or secret access keys in your code. So we don't do that here. I'm going to open my repository in a new tab here and then create variables for my access keys and secret access keys. So click on settings here, go to CI/CD. Inside CI/CD, you will find variables here and click on expand variables. In this, I'm going to add a variable first for my access keys, second for my secret access keys. So this is a description which is optional. You can choose to add it if you want or leave it. So in here, I'm going to name this as my underscore AWS underscore access underscore key and put the value of that here. So this is now my access key. Similarly, I'll do the same for my secret access key as well. So I'll say my underscore secret underscore key and then put the value of the secret key here as well. Do not try to use my keys because I will be deleting this once I complete recording this video. So you have to use your own account, you have to use your own keys. Now this is done. I've created my access keys. I've created variables for my access keys and secret access keys. Let's use it in the CI/CD code here. So I'm going to define variables, and I am using two variables, one for access key, one for secret access keys, but I will also use one more for region. So I'll say AWS underscore access underscore key underscore ID is the value that is stored inside the variable. The variable name is my AWS access key. So I'm going to put that here. Similarly, AWS underscore secret access key, secret access underscore key equals to the value stored here in my secret key. Okay, along with this I also need a region. So the region is going to be AWS underscore default underscore region, and the value is US-east-1. So US-east-1. Okay, so this is our code, which is almost ready. We can also do more things in it, but for now I'm going to leave it as it is and see if it is actually working or not. One more thing to note here is, you can see there are 4 stages here: validate, plan, apply, destroy. Whenever we run this pipeline, it will first go through the validate section, check if everything is working fine. If it is working fine, it will go to the next stage, which is the plan here, and it will create a plan. If everything is okay, it will go ahead and apply it. If everything is created, it will also go ahead and destroy it, which is not what we want. So we want to have validate and plan automatically running, but we want to have apply and destroy manually. Sometimes in many companies you have these manually done, because once the plan is created, a senior developer or a senior DevOps engineer will manually run the job to apply or destroy resources, which is what we want in our project as well. So how to do that? I'm going to just add another line here saying, when do you want to run this particular job? So I want to run it manually. So I'll say when manual, and do the same for my destroy as well. So I'll just add another line here saying, when should this job run? It should run whenever I do it manually. So now this is our code here. Let's commit this. I'm going to say add CICD pipeline file on the main branch. I'm going to say commit now. Once it is committed, you will be able to see a symbol here. So we got an error saying failed. This is because I think the configuration YAML is not correct. Let's see what is the problem. The problem here is I'm using equals to symbols. I should be using colons here. So I will edit this now. GitLab also has many different features. You can see it always gives you what is wrong with your CI/CD pipelines. I'm going to just change this to colons rather than equals to symbols, which is the problem here. So I'll just change it, and now you will be able to see that the pipeline syntax is correct. So once it is done, I'm going to just go ahead and commit change with the message update gitlab.ci, and the pipeline syntax is correct. The pipeline is also running. You can confirm by going to the pipeline section here, and you will very soon see that it is running. Let's check the jobs. So right now we have 4 jobs. As you can see here, the validate job is running. You can also check the logs for it by going inside it. If you remember, we ran before script, which should show us the Terraform version and also Terraform initialized. So let's see if we get that here. So we get the version and we get the init as well, but there's something wrong with our code. It says a managed resource security group has not been declared in module.vpc. So the validate gave us an error saying there is no you don't have a security group with this name, which is true because the name of the security group is not SG, it's actually pb_SG. Let me show you that. So right now we are inside cicd.tf. Let's go to VPC. Inside this VPC we have a security group created with the name pb_SG, whereas in the outputs we are referring it as just SG, which is not correct. So I'm going to edit it real quick just to show you. Whenever I edit it, the pipeline is going to trigger again and again, and also update it in the infrastructure if everything works fine. So let's change that very quick here. This is GitLab's own IDE. in this I'm going to just change this to pb underscore sg as we have in here. So pb underscore sg. Once I change this, I'm going to commit by saying changed sg name, commit to main. I'm going to click on continue and the commit has been made. Let's go to the project and you will see a pipeline is going to run again. So here is the pipeline symbol which is running right now. Let's see if once everything is working fine, it should bring us to apply, where we are going to manually apply it, and we should be able to see that EC2 instance, security group, VPC and subnet is created. So here we are in the validate stage. You can check the logs here. Very soon it will show us the logs. If it is correct, it will give us a message saying the configuration is valid, and it will then move on to the next stage. So we have seen that it shows us the version, also give us Terraform init. It also tells us the configuration is valid. Let's go and see if it is going to the next job. So the next job is running, which is the plan. So stage is plan here. Let's see if we get the plan saying 4 things are going to be created. Okay, so job has been succeeded and you can see plan says 4 things are going to be created, which means our pipeline is working properly. Now when you go back and you check at the pipelines here, these 2 are manual jobs that you need to run it manually, and this we have done it ourselves by making the change. So I'm just going to say run here. When I say it run, it will start running the Terraform apply command which we have for this particular stage. So this is how you can automate using Terraform and CI/CD. I hope this project has taught you a lot. If you have any problems, any issues with this project, you can let me know in the comment section, and feel free to use the code. I'm going to paste the link for this repository in the description. Feel free to create this project yourself, share it on LinkedIn, because this is actually a very useful project, because this is how we do infrastructure deployment on production. So I thought this should be something that you need to know as a DevOps engineer. So you can see module VPC has been created here. Security group has also been created. Subnet is also created. It's right now creating EC2 instance. So let's check that in our AWS here, and you can see job has been succeeded. Apply complete. I can confirm by going to my AWS and checking if the EC2 instance is running or not with the name my server. So in the EC2 dashboard, we have a server running with the name my server, which was created now, and it's T2 micro. So everything is automated now. Whenever I make a change, which can be adding a new resource or deleting a resource or anything, it will automatically update things without me manually running the commands. So this is how you can use Terraform and GitLab CI. Let's also see if it can automatically delete things or not. So I will go to my jobs again. Let's go to jobs, and you will see that the delete is also a manual thing, which is actually good. You should make it manual, or else whenever you make a change, you can accidentally delete everything in your account. So let's click on run job here, and it will start deleting everything, because the command it's running is terraform destroy -auto -approve. So this is the project. Let's wait for this to be deleted. So it has started destroying. It will destroy 4 things which are created: VPC, SG, SN, and EC2 instance. So it has successfully deleted everything now. So we have automated. We have learned how to automate Terraform deployment using GitLab CICD. You can do the same thing using GitHub, Circle CI, Jenkins, anything you want. But this is the basic architecture. I don't want you to learn tools. I want you to learn the concept behind the tools. So how you can automate it, If you want, you can try out this with GitLab. If you want, you can also try out this with GitHub or Jenkins or anything you want. So this was our Terraform pipeline project. Completing this project will help you understand how we deploy infrastructure on the cloud in production systems. I hope this video was informative. If you have any questions, any doubt, do let me know in the comment section. Try it out, share it on LinkedIn, and do tag me. Thank you and have a good day.